All right, so hello and welcome to lesson 2 of our Intro to Java class. Today we'll be covering variables and methods. This is absolutely essential. If you do not understand this today, you're going to have a problem. So, if at some point you have questions or something does not make sense, please immediately interrupt me and be like, that doesn't make sense, help. Okay? Because it's very important that everyone understands this lesson. If you don't understand this, nothing else you do later will help you. Okay? All right, so let's get started. Huh? Okay. Today we're going to cover what is data when it comes to Java, what is a variable, what are different types of data that you can use, along with what a constant is. And we'll be going over functions, how to use functions and methods. Hint, you've been doing it already. And defining your own functions and methods, which is super useful. Okay. So what is data? Well, it's just ones and zeros, right? Um, now, computers only understand electricity or no electricity, 1 and 0, right? Um, so all of data is just translating electricity and no electricity to something meaningful, like a number or a letter or some structure of data, okay? Now, on a day-to-day basis, you don't need to know how to convert between ones and zeros and anything else. However, if you at least have some idea of how this works, at the times when you do need it, having at least a little familiarity will be good for you. Okay? Um, so if this part doesn't make a huge amount of sense, it's okay. The other stuff is more important. Um, so this 1 and 0 system, we call it binary. Okay? For those binary in English language roots, bi means 2, nary means number system. So a number system based on the number 2, because you have only 2 digits, 0 and 1, right? When we count and we do numbers, we use a decimal system. Deci is 10, right? Because we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 10 digits. Binary is just 2 digits. Now, everything in your computer is represented as binary, a 0 or a 1. And the computer translates between binary and these images you see on the screen, this color, this text. It's all just ones and zeros, okay? You've probably heard of like megabits and megabytes or gigabytes and gigabit. These are different things. A bit means a 1 or a 0, okay? A byte is 8 of those, okay? So 8 gigabits is 1 gigabyte, okay? In networking, they'll talk about bits a lot because they're sending individual ones and zeros across a physical wire, right? But in programming, we talk about bytes more often because we're storing things on a disk where data is grouped in sets of 8, okay? Not hugely important, but sometimes helpful. As I mentioned before, binary is a base 2 system, again, 0 and 1. Decimal, we have 10 digits. So this might be a bit tricky to understand if you're not mathematically inclined. Like I had a really hard time with this because I'm crap at math. But in a base 10 system, when we have the number 4, for example, what we're really writing is the number 4 times the number 10 to the 0th power, okay? Because it's the first spot, the 0th spot. In programming, we start counting from 0, okay? So does anyone remember what 10 to the 0th power is? 1. Yes. So what's 4 times 1? Yes. So that's why when we write the number 4 in the rightmost spot, the 0th spot, it's just the number 4. If we write 4 and then 0, that's 10 to the power of what? If the first one is 0, what's the next one? So if we have, let's say we have this number, the 7,654 number, right? This first position where the 4 is, That's the 0th position, okay? Following that, this is the tens position, or the 1 digit. 0, 1, 2, 3, 4, okay? So 5 times 10 to the first is 50. 10 to the first is 10, right? What's 10 to the second? Yep, 10 to the third. You got it, right? So each time we move to the left, we increase the exponent, okay? And that's how our base 10 number system works, right? When you get into like really, at least this is what my friend who knows math explained it to me. When you get into the really details of math, we humans just made up numbers. Numbers aren't actually a thing. There's no such thing in the universe as a number. We made it up. And when you look at math, this is actually really important, how we count numbers, right? So we're all used to this and we don't think about it. But in reality, it works this way, this big long mess, okay? In binary, the system is the same, except instead of using base 10, we're using base 2, okay? So what's 2 to the 0? Correct. What's 2 to the first? What's 2 to the second? 2 to the third? Nice. 2 to the fourth? Nice. Excellent. So in this case, we have 0 here, so we can ignore it, right? 0 times anything is 0. This is 1, right? Times what? 1 times 2. So what does that give us? Okay, so we put a 2 here, all right? 0, so we ignore it. Now, 1 times 2 to the third, what's 2 to the third? 8. Yep, so 8 plus 2 is 10. That's it. You can read binary now. And you can just keep counting this way, right? Now, normally what we'd do is, in programming, we don't just have one big, long binary number, because that would just be one number, right? We have sets of 8 numbers. That's why we organize things into bytes, sets of 8, right? So 8 digits. So that is basically binary. If you understand that, you understand binary. Good job. If you don't understand that, this part, it's okay if you don't understand it. The other stuff is more important, all right? And everything is derived from numbers. That's the important part. So this looks really scary. I promise you it's not that scary. So in decimal, right? So I mentioned everything is numbers, right? So the letter M, it's really just the number 109, okay? That's how a computer gets from the zeros and ones to M, right? Obviously 109 written in binary, but that would be really long, so we're not going to write it here. But you get the idea, okay? That's how we go from binary to interesting things like letters. Questions about that? Yep. So I'm going to keep this short. Images are often represented pixel by pixel because the screen is just a whole bunch of tiny dots, right? And usually you represent pixels as a red value, a green value, and a blue value because the LEDs are actually just a red light, green light, and blue light all put together. So depending on what kind of monitor it is, what kind of video card you're running, it's usually just 3 binary numbers. One representing some amount of red, some amount of blue, some amount of green. And if you can write that out, you can write an image file. I believe that format is called a bitmap because you're mapping bits to an image. There are other formats that are much smaller because you can imagine like if you have 3 binary numbers for each pixel of an entire screen, that'd be a lot of data, right? So there's different formats like JPG, PNG, all these kinds of things to make it smaller, but in essence, it's just red, green, blue. Does that answer your question? Cool. Similar thing with audio. Audio is represented with just volume, right? Volume per sample. So you might have 44,000 samples per second. And so that means for 1 second, you have 44,000 binary numbers. And so that can either be, and that determines the volume, which determines the frequency, and that's how you get sound. So everything can be represented with numbers. Computer science is really just math, but not anymore. Now, you don't need to know a whole lot of math to do computer science, which is great because I'm terrible at it, and I imagine some people here may not be great at math too, and that's okay. You don't need to. What's up? Cool. We're good then. We're good. All right, so good to move on? All right. So cool. You understand what data is, right? It's just ones and zeros, but how do we do stuff with it, right? In programming, we store data in something called a variable. Now, in programming, names are often either pretty direct metaphors or just a direct description. Variable just means something that changes, right? So when we say a variable, what we really mean is some data that changes, okay? Now, variables are a way to label some data, right? So you can take some number or some text or some binary or whatever and label it with a name, okay? And then you can track if that changes, or you can change it, or whatever. When you're actually doing your programming and you're creating your variables, you should be very careful about how you name your variables, because maybe a week from now you're going to need to read this code again, and if the name doesn't make sense, you're going to be like, what is this number 42? Why is this number 42? I don't know why it's 42. But if it's stored inside a variable that says distance to the door, you're like, oh, now I know what 42 is. 42 is the distance to the door, okay? So that's why, oh, and in programming, they say there's really only two hard things: caching, which you're not going to learn here, and naming things. Naming things is hard. So take some time to think about how you should name things, because later when you read code, if you spent time to think about how you're going to name it, future you will thank past you. Okay? So far, so good? Cool. Now, the best way I've been able to explain variables is using the metaphor of a box. Actually, do I have a box? I don't have a box. But, yeah, I don't have a box. But we're going to draw. So if I have some box, what the hell am I doing? That's not a box. If I have some box, right? Right? And the box might have a label, right? So let's call it distance, right? That's the name of my variable, right? And then this box also has some dimensions, right? It has some size, right? Like this is maybe 2 by 3. I don't know, whatever, right? So there's some size, right? The size determines what you can put in the box. If the box is too small, you can't put a big thing into it, right? And then lastly, you have the thing you put in the box, which could be the number 42, right? So this is a good way to think about variables. A variable is just a box that has some name that acts as a label. It has a limited size based on the type of data that you say it's going to store. And then you have the data that you put inside it. That's a variable. Now here's the thing too, this can change, right? You can take stuff out of the box, change it, put it back in, sort of thing. Okay, no problem, we can do that. That's what makes a variable variable. Vary means to change, right? So far so good? Cool. I wish I got that on the recording, but nothing's perfect. Now, when we create a variable, we call this declaring the variable, okay? When we declare a variable, we must define the type of data it's going to store, right? Is it a number? Is it text? Is it binary? Whatever, right? And the name of it. right? You're basically setting up the box. You're building the box, right? The box has to be a certain size. It has to have a label. That's it, okay? Then you can initialize the variable. Initializing is just the first time you put data into it. It's the first time you put something in the box. That's initializing a variable, okay? This is just vocabulary, okay? When you talk to a developer, they're going to say, oh, declare an integer variable. And you'll be like, okay, I need to make a new variable that's type is integer and give it some name, okay? Now I talk about declare and initialize as being two different things, and they are, but you can do them at the same time, okay? This is all abstract and a whole lot of information that's just kind of sticking in your head. Let's illustrate it. So, when you declare a variable, when you're writing your Java code, it looks like this. You have some type of data, all right, followed by the name of the variable, the name of the box, okay? The types of data we're going to go over in a minute, okay? But this one is integer. It's just a whole number. So we're declaring a variable that can hold an integer. It can fit an integer inside it. And then its name is my first integer variable, okay? Now, and then later we can initialize by setting, so in programming, a single equal sign means whatever's after the equal, store it in whatever's before the equal, okay? So it's not actually equal, it's more like a sign, okay? So when you see equal, you should think a sign. So my first integer variable is assigned the number 10. Or if assigned doesn't really make sense to you, you can say is storing the number 10 or is saving the number 10, something like that, okay? So this is basically saying that number 10, we're putting it in the box labeled my first integer variable. Does that make sense? Cool. And now we can do both of these in the same step like this. It's just these two things combined. Questions about that? Cool. Going too fast, too slow? Okay. Joelle? You okay? Now, variables can change, right? They vary, right? So if we declare and initialize my first integer variable, we can actually take my first integer variable and add 10 to it. Now, in programming, when you use the name of a variable, what it's going to do, it's going to grab the box, it's going to take whatever's out of the box and it's going to use it, okay? So if I set my first integer variable to the number 10 right here, this becomes the number 10. It takes the number 10 out of the box and puts it right there. So what does this become? To the right of the equal sign here, what does this become in just numbers? Huh?
It'll become 20.
Yes, 20. It becomes 10 plus 10. Yep. So then what will this print? 10. Or no, not 10. 20, yes. Because, yes, we took my first integer variable and we assigned it to the previous value of my first integer variable plus the number 10. Okay, so we changed what was in the box. We took what was out of it, we added to it, and we put it back in the box. Understand? Cool. Now, a little note. This kind of operation is very common. 이렇게 자주 해요. We do this very often. So they made a shortcut. This plus equals means the same as equals the same variable name plus. Okay, so these two lines are the same. Okay, good. Hint that will help you in the homework. Yeah.
Is system is the same like print in other languages, right?
Yeah. Yeah. I was kind of taking for granted that you guys might have figured that out during the first lesson. I apologize. I should have been explicit. Yes, this right here prints whatever's in between the parentheses to the screen. Okay. Good question. Thank you for asking. Anything else before we move on? Cool. How are we doing on time? Oh, we're doing pretty good. All right. So I mentioned earlier, so that this variable we declared as an integer, right? That's one type of data. There are many types of data. Okay. Um, Now, different types of data are different sizes, different lengths. Okay. This is where the binary comes back. Okay. So, for example, an integer in Java. Now in different languages, this data of the same name may be a different size. So when you change programming languages, you'll want to check this. Okay. In Java, an integer is 32 bits, 32 zeros and ones. Okay. So that means the largest possible integer is the binary number of 32 ones. Okay. That's the biggest possible integer you can store. Except -1, because in Java what they do is to represent positive and negative numbers, the first digit is a 1 or a 0 for positive or negative. So it's actually 31 bits for the number because the first one represents positive or negative. So the minimum value is -2 to the 31st. Yeah, what's up? That's an integer is 32 bits, I think. The minimum value? Not 2 to the 31. Because you have the 32 digits, and then you're removing one digit. Because remember here, oh, come on, right? Each decimal place. Yeah. Yeah, exponential math is a little funky. I understand what you're thinking. Um, Exponents. Good thought though. Um, so yeah, this is the smallest possible value. This is the biggest possible value. Again, because one bit is used for positive or negative, and the rest are used to represent an integer. Now, there are in Java you have primitive types, which are basic, just binary to data. Okay, and then you have objects, which are big and complicated, and you will learn them, but not today. Okay, today we're only going to mess with primitives plus string, and we'll cover what string is later. Okay, if you're curious about these, here's a link. And this link has information about all the different data types. Okay, and I'm sure there's a Korean version of this too, if you need. So this describes, I list them here, byte, short, int, float, mo, and you can find more info here. Okay, cool. I want full screen again. Yeah. All right, questions? Cool. Do I? Yes, okay. So different types of data can do different types of work. Numbers can do math. Other things do other things. Most of these are numbers. Okay? So short, int, long, float, and double are all different ways of writing numbers. Okay? They all store different types and sizes of numbers. Okay? So they support mathematical operations like plus, minus, multiply, divide, modulo. Should I teach modulo? No, we're not going to cover modulo. You'll need it sometimes, but not today. And then the other type of primitives are char and boolean. Char or char, it can be either one, char, char, they're the same. Short for character, a single character of text. Okay? So it could be like a, or a space, or a period, or han, that kind of thing, in Hangul, right? Now, if you want, now one character, right? If I want to print out comments or something, right? I can't do that with one character. I need many characters, right? So if I want to do text, I need something more than a character. There is an object type called string, okay? And a string basically is you have a character and a string between this character and the next character, okay? So you string the characters together to make text. That's what a string is. String, text, same thing, okay? I'm only teaching string now because you'll need it for practicing, and it's just easier to do things with words than with numbers if you're not a math person like me. Like me being a not math person, I mean. Now, in terms of these operators, you can actually use plus with string. So if you do hello plus world, you'll get hello world. Okay, so you can do that with strings. All right. Minus, multiply, divide, you can't do that. It doesn't make sense. It should give you an error. Okay. Does that make sense for char and string? Good. And then Boolean. Boolean is super helpful. It's true or false. That's it. Okay. If you need to switch between them, you can use the bang symbol or the exclamation point, and that means not. Okay. So exclamation point, bang is not. Okay. So if I do bang true, what is that? Correct. If I do bang false, what is that? You got it. It just switches it. So far, so good? Questions? Yeah. Yes. Oh, this one? Oh, okay. This is modulo. Yeah. Modulo is remainder. It's the same thing. Yeah. Screw it. I'll teach it. So what is 3 divided by 2? 1.5, right? You can also think of it as equals 1 remainder 1, right? You guys know remainder? Cool. Now, if I just divide integers, I'm going to get an integer. So if I in programming, if 3 is an integer and 2 is an integer, I'm going to get 1, which doesn't make a whole lot of sense, right? However, there is a way to get this number, okay? If you do, if you do 3 and then percentage or modulo 2, it's going to give you only the remainder, okay? Actually, this might be a bad example. Let's do 5 modulo 3. That's going to be what? 2. Okay. So this can be really useful in cases like odds and evens, right? If I do 4 mod 2, what is that? 5 mod 2. 1. Right, because it's remainder, right? So 2, yeah, 2 times 2 is 4. That goes into 5, and then what's left over? 1. 6 mod 2. Yep. So this is even, odd, even, odd, even, odd, even, odd. You've seen websites where they have a table, and then every other row is a different color? It's that. They're just doing this. Really easy. So yeah. Questions about modulo? Cool. All the other operators, plus, minus, multiply, divide, those are the same. No surprises. Cool. I will add notes about the modulo operator to this, okay? For when I post this online for you guys to see later. Or it's already, I'll add it after this. All right, so questions about, so that's it for variables. If you understand the whole declaring, initializing, variable size, label, putting something in, taking something out, you understand variables. Good job. All right, what's up?
I understand all the other ones, but short, I don't know.
So short, int, and long are all whole numbers. Short is, I think, 16 bits. It's just how much data. Yeah. So if we go, so short is 16 bits. Int is 32 bits. Long is 64 bits. That's pretty much it. That's the only difference. Does that answer your question? Cool. Other questions? Float and double. Float is a decimal point. And it's crap. I think that's 32 as well. Yeah. Float is 32-bit. Double is also a decimal point, but it's double the size, 64-bit. So you can get more detailed with your number. Okay. Now there is floating point arithmetic, which if you end up doing a lot of math stuff, you'll want to study that. But in your average day, you're probably not going to worry about that too much. Okay. So if you notice that you're using floats a lot in your programming, you may want to look up floating point arithmetic. If you think you're not going to do that, ignore what I just said. Good? Cool. All right, any more questions about variables? Cool. Constants. They're the same as variables, except you cannot change them. They are constant. They do not change. To make a constant, it's the same as a variable, except before you specify the data type, you say final. Okay? If you do that, you're done. It's constant, it cannot change. So if you try to do something like this, where you change the value inside it, you'll get an error. Cannot assign a value to final variable. So Java doesn't have like constants, it has final variables. In every other language, we call that a constant. Okay? Questions about that? Yeah. Constants, yes. Constants are mostly useful for readability. Okay? Because if I keep writing the number, again, 42 everywhere, I'm going to be like, what the hell is 42? And then if I want to change my code and have that number not be 42, I have to go to everywhere I wrote it and I have to change it, right? That's not fun. Instead, I can just write a constant and just use that name everywhere. And then if I need to change it, I just change the constant and then it's done. Does that make sense? So usually, as kind of tradition or convention, when we create a constant, instead of following this kind of naming scheme, we write constants like this. If you see this, it means it's a constant. It's not changing. Okay? So again, if you keep writing the same value, like the same text or the same number or whatever, over and over and over again, stop that, define it as a constant, and then just use the constant name. Because then if you need to change it later, it'll be much easier. Okay? And another important reason for using something like constants is good code sounds like English. Okay? So if you have a constant of, let's say you're doing, let's say you're making a game, right? And the game has jumping, right? You need to do some math about gravity, right? So you might do something of, oh, his speed is, oh crap. His speed is the amount of time he's been falling times, then you'd have a constant gravity, right? Instead of 9.8 or whatever. You might be like, wait, what was 9.8 again? These kinds of things, okay? Yep, questions about constants? They're pretty simple. Cool. All right, now the fun part. Functions and methods, okay? All the other stuff was just storing data and manipulating data in a basic manner. This is where programming gets really nice. Because up until now, when you're writing code, it's just step by step by step by step, right? Not anything really interesting. Functions allow you to basically pull out pieces of code and reuse them and do them again and again, these kinds of things. It allows a lot more flexibility. Well, Yeah, let's call it flexibility. Now I'm going to use the word function and method interchangeably. I'm going to switch between the two. They're the same thing. Okay. Technically, in Java, they're a method due to some semantic stuff, but in real life, function, method, same thing. Okay. Functions and methods are a way to take a whole bunch of code, and instead of just copying and pasting that code again and again, you just define some name. Functions are like a variable for code, right? So you can have a whole bunch of code, and instead of writing that code over and over again, you just have some name to reference that code. And then when you write that name, that code will be executed. Does that make sense? A little bit? If it doesn't make a whole lot of sense, as we continue, maybe it'll coalesce more in your mind. Every programming language has functions already defined for you, okay? In every programming language, 모든 프로그래밍 언어에서 이미 펑션이 있어요. But you can also create your own. 새로운 또 만들 수 있어요. We're going to cover both, okay? Now, you've actually already been using a function. When we've been doing the system.out.println that you did in the homework and that I use as an example, this println is a function. You've been using functions already, okay? Questions so far? Cool. When you call a function, there's three parts. One is the name of the function. Two is the inputs to the function. We also call inputs parameters or arguments. Again, these three words mean the same thing in this context. In other contexts, they're different, but for this context, they're the same thing, okay? And then the output, or what's returned by the function, okay? Now, you've been using these two already, okay? These two things, when you've been doing println is the name of the function. And then what was in between the parentheses was the input. So you've already been doing that, okay? Outputs and returns we'll get to in a minute, all right? Now, every function can have 0 parameters or a lot of parameters, a lot of inputs. There's a limit. I don't know what it is. You're probably never going to hit it. But you can have a lot of inputs. And the function can return nothing. It can output nothing, or it can output something. It can do both. But all functions must have a name in Java. Okay, that's not 100% true, but for purposes of your learning today, every function must have a name. In reality, that's not the case, but for learning today, every function must have a name, okay? These three parts together, we call it the function signature, okay? This is a word you will want to know because when you're working with other developers and you're saying some function is acting weird, they may ask, hey, can you show me the signature? This is what they mean. What's the name? What's the input? What's the output? Okay? Good? So one good example of functions that you can use is Java's math class, its math package. So if we look here, ignore all this. These are all different functions that Java already has for you, okay? For example, where's the, oh yeah, max, right? Let's do this one. So this is the signature for max, okay? It outputs an integer. Its name is max. It takes in one integer and it takes in a second integer. That's the function signature, okay? Does that make sense? Cool. Static, don't worry about that. You're not learning that yet. Later. All right? So, using max as an example, Again, I put the signature right here too. But this is an example of using all three parts of a function. So we're calling the math.max function. This is the name. We're giving it the inputs of 2 and 3. And then when this function runs, it's going to output something. When it outputs that something, that output replaces this. Okay? Now, the max function specifically takes in two integers, and whichever one is bigger is the one it's going to output. Okay? So which of these will it output? Yes, 3. So because 3 is the output, this math.max gets replaced with 3. So then what is bigger number going to be? Yep. I know I'm asking, sometimes these questions might seem obvious, but I need to make sure that you're following the reasoning, okay? So yes, 3. That's pretty much it. Okay? Yes. Mm, yes. Uh, yes. So thank you. You discovered a gap in my lesson. Good question. Void is used to describe no output. Okay? So for example, if we look at oh, come on, dude. Oh, come on. Really? Hold up. Print stream. Sorry, give me a second. Needed to navigate the here we go. So string. Here we go. This one. This right here. This is the print line function we've been using. You'll notice here the output type is void. Okay? Again, thank you for asking that question. Void means there is no output. So if I try to do something like if I try to do something, I don't know, int some variable equals system.out.println hi, this will not work because this is the same as saying nothing. And you can't do that, right? This has no output. Output also. Okay? That's what void means. It means you can only do this. It means you cannot use the output because there is no output. Does that answer your question? Cool. Correct. Yep. So it does not return anything. There is no output. The output type is void. Void means a lack of anything. Nothing exists, right? So when you say there's a void output, it means there's a non-existent output. There is no output. Okay. Does that answer your question then? Sorry, I missed it. Okay. Uh, mm, okay. good question. So, max is actually a good example for that. Oh, I was hoping to not teach this today, but actually we're doing good on time, so yeah, I'll teach it. In Java, you can have a function with the same name with different types of inputs. So really, a function can only accept one combination of inputs. Okay? However, you can have multiple functions with the same name but different inputs. Okay? So when in the past, when you've been like, oh, I can give this an integer or I can give it a string, what? It's because it's actually two different functions. So if you look at max here, max has a version that accepts two doubles. It has a version that accepts two floats. It has a version that accepts two integers. Okay? There's many different functions named max. And so that's why there may be that confusion of, oh, I can give it all these different types, because there's actually different functions that accept each of those types. Does that make sense? Cool. When we do this, when we have the same function name, but different inputs, different parameters, we call this overloading. Okay? So that's a vocabulary term. I apologize, that's not in the slides. I'm going to add it. I was planning on teaching it later, but whatever, we're doing it now. No, honestly, it makes more sense to learn it now. I should have included it in this lesson, but I was worried about time, so I didn't. But it makes sense to learn about overloading now. So that was a good question. So yeah, max has 4 overloaded types: a double, a float, an int, and a long. Okay, as an example. And then print line has, oh geez, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 overloaded types. And that's why it may feel like, oh, I can give anything to this function, because it has so many different overloaded versions. Now, it is a little bit more complicated than that, because objects have this kind of hierarchy where you can put children in place of parents and stuff. But we're not learning that yet. That's complicated, and that is not today. Okay? But overloading means the same function name, different function inputs. Now, it could also mean that you get different outputs too. For example, max, the double version, outputs a double. The float version outputs a float. Int version outputs an int. You get the idea. Okay? Now, these don't have to be the same. They just happen to be the same for this function. Okay? Does that make sense? Questions? So who can explain to me in their own words what is overloading? Overloading, Moyo.
Function having different
Different types of inputs. Yes. Now, oh, sorry. One more point of clarification around overloading. It's not only the types of parameters; it's also the number of parameters. Okay. I don't think math is actually going to have an example of that. Nope. Nope. It looks like math doesn't have an example of that. Maybe a print stream does. Yeah, here we go. So, for example, this printf function, one version takes in 1, 2, 3 inputs. Another version takes only 2 inputs, right? You can do that. That's no problem. That is valid overloading, okay? So when overloading, you can have different types of inputs and a different number of inputs, okay? Questions about that? Cool. All right, so where's the button? Okay. Cool. So that's all using these different functions, but what if you want to make your own? What if you want to define your own function? This slide is way too dense. There's way too much information here. Okay. Previously, I explained to you the signature, the output, the name, the inputs, right? When defining a function, you do the same thing, okay? This is actually a function definition right here. This is an example. We have the output type here, the function name here, and the inputs in between the parentheses, okay? Now, remember, a function can also accept no inputs. It can just be open parenthesis, close parenthesis. That's no problem, okay? When should you define a function? Basically, if you find yourself copying and pasting the same code, don't do that. Write a function with that code inside it and just use the function. That will make life easier for you. Okay. There's also other cases there are also other situations where your response should be, oh, I should make a function for this, but we're going to cover that later. Okay. So in this case, we're defining a function called add. It takes in 2 integers and it outputs an integer. Okay. Now, when you define a function, you see this a and b. I think we had a similar thing on Max. Whoops. All right. They also use crap. Yeah, they also use a and b, right? Because there's not really a meaningful name for these things. A and b effectively become variables. Okay, these inputs act like variables. So later, if I call add and I set the first number to 1 and the second number to 2, a is going to equal 1 and b is going to equal 2. Does that make sense? So then if I called add with 1 and 2, what would my output be? Kind of skipping ahead here, but you can guess. Yep. Now I kind of skipped a part, but that was an excellent guess. There's a keyword called return, okay? And you can only use it in a function. And return says that after the word return, whatever comes next is the output of this function, okay? So the output of the function is just going to be a plus b. So whatever a plus b becomes is what the function outputs, all right? So what would the output of this be? You got it. What would b be equal to? What would a be equal to? Good job, guys. Questions? Cool. One last thing about return. Return stops the function. Okay. So if you write return and then you write some code after it, that code after it's not going to run. I think Java might actually prevent you from compiling it. I'm not sure. But yeah. Oh. I made a mistake. We don't have any exercises. So I'm going to make up an exercise right now. So let's go ahead and actually, you know what? I kind of like this, going over the theory, and then we're just going to try it, see how much you remember, and then if you don't remember things, we can just remind you. That's actually a good system. So let's open up Visual Studio Code if you have not already. You okay, Yuhi? Kinshana? And you can either open a new project or you can use the old Hello World project. I'm going to open a new project because I'm going to post this online. So we're going to do this. Ah, too much junk. Okay. I should rename that folder. Huh? The hell is this? What? CodeSeoul? No. Learn teach CodeSeoul? No. What? Oh, did you see that? Oh, thank you. Cool. All right. Why is there nothing in here? Ah, right. Thank you. I need to move that folder. We're just gonna go in here, I guess, and you can make it anywhere on your computer. I'm just trying to keep my stuff organized. So let's do Java. I'll have to find the other folder I used later, and I'm gonna make one for variables and methods. Cool. All right, use this. Okay, great. So I'm gonna make a new file. I'm gonna call it I'm just gonna call it lesson2.java, but you can call it whatever you want. So let's see who remembers their homework. What does every Java file need to have? Begins with a C. Yes. Hello, VS Code. Thank you for interrupting me. Right, and the class should be the same name as the file, right? You guys remember that? And then what do I need after that? Yep, curly brackets. All right, so I'm gonna wait for everyone to get set up. Give me a signal when you're at this point. Cool. You good, Yuhi? Good. Okay. Now, in the first class, I recommended you memorize something. Who remembers how to do the main? Well, actually, first, can anyone remember it without looking? No? No? Yeah? All right, go for it. Yeah, just tell me. Just tell me. Yeah. Yeah. Yep. Public static void main string args. Good job, dude.
I think if you also just write main, it comes, right? If you just write main,
Maybe.
yeah, it comes.
Nice. That's really good. Yeah. So thank you, Sam. Thank you. If you just type main, Visual Studio Code will autocomplete for you. I think other IDEs do that too. I was actually trying to not do that because you should memorize this in case you don't have a nice IDE, but whatever. All right, so has everyone got this up? Cool. Don't forget to save. What is going on with your... okay, hold up. So what you got here? Your folder is named lesson2.java. This file doesn't exist anywhere. So what we're gonna do, let's rename this folder. Let's just rename this as lesson2. And then inside here, we're gonna save this file as lesson2. I'm gonna call it lesson2.java. And then we should also change this to be a capital L because English is stupid with its capitals and lowercases. And now I think you're good. What is it complaining about? Packages. I think you can ignore that. Okay. All right, cool. So, let's do here we go. I want so in our new program, I want to track the number of students in the class. How can I write a variable to store that data? I'm asking you to tell me what to type. Int? So why? Why int? Because we can't have a person. Yep. Cool. And then we could use short, but it doesn't really matter. But yeah, int sounds good. So int, then what? Number of students. That sounds like a good name. Then what? Let's do both. Let's do both versions, just for demonstration. So let's start with doing initialization and declaration separate. So if I want to only declare this, what do I do next? Thank you. All right, now if I want to initialize it, what do I do? The what now? Sorry, I just didn't hear you. Yeah, it's about the same, yeah. So I'm sorry, I didn't hear what you said at the beginning though. To Oh, okay. So how would I initialize this? 2, 4, 6. And then what? Cool. Excellent. It's just warning me that I've declared a variable and I'm not using it. It's a way to keep your code clean. Good question. I'm going to wait for people to type this. Has everyone caught up already? Okay. Now, if I wanted to combine initialization, okay. Is this initialization or declaration? Yes. Is this initialization or declaration? Good. If I want to combine these, how do I do that? Okay. Like this? Like this? Ah, like this. Cool. Ugly, but yes. I mean, you're right. I'm just being an ass. Yeah, there we go. So this is initialization and declaration in the same step. Okay, good. Does everyone remember that? Cool. Now, so we're running a class here, right? And maybe a new student has shown up. I want to now that this function is going to be kind of stupid, but again, just for practice and demonstration. I want a function that when a new student registers, I need to increase the number of students by 1. Okay. Can someone guide me on how to write a function like that? But first, a little bit of guidance. So this is one function. You can't define a function inside another function. Oh, shit. No, go away. Damn it. No, I didn't want to do that. No, no. Go away. Okay. Get out of here. Okay. So this is one function. I can't define a function inside another function. You can't nest functions. Okay. So what I need to do is after this function, I would define a function here inside the class, but outside of the other function. Okay? Give everyone a second to catch up and get things written. So, someone who is not Nicholas, because he knows a lot of stuff already, Who wants to guide me in how to write a function to register a new student by increasing the number of students? I want a function that does this. Someone tell me what to type. There's a few ways to do this. So how you want to do it is your choice. And this does take some time to think, so I'm giving you time to think. Don't think that I'm just chilling. I can think of two different ways to do it. Actually, no. With what we have, there's really only one way to do it. Because I haven't taught you guys scoping yet. Okay. So let me be a little more specific then, because you guys probably don't have enough knowledge to make that jump between the two ideas. So I want a function called register student. Okay. It takes in the current number of students as an input, and it outputs the new number of students, which should just be the current number plus 1. Okay? Does everyone understand that? Cool. So given that, can someone guide me on what to type? Sorry? I'm sorry, I couldn't hear you. You want to reuse that? So that function doesn't exist in Java. We made that. Yeah. But you can use it as an example to help you write this one if you want to look at it. No? All right. So let's walk through. I'll walk you guys through this one, and then we'll do this exercise again with a different function. Okay? So I want a function called register student that takes in the current number of students and outputs the new number of students. The new number of students is just the current number plus 1. Okay? So we can write it like this. Our output is the number of students, and it's going to be a whole number. You can't have like half a person. I'm not going to cut Jiha in half, right? So, and we're going to call it register student, right? It takes in one input, right? And that input is the current number of students. We know that we're only using integers, so we're going to say int current number of students. Okay? This is the function signature, right? Output, name, inputs. Does everyone remember this? Kyoki-sayo? Now, yep. So current number of students plus equals 1. There's another way to write this, but not today. And then we want to return the current number of students. How are we doing on time? We're doing really good on time. Man, you guys are way faster than the classes I taught 2 years ago. Yeah. Oh, thank you. I have not taught you static. What you mentioned is unfortunately not correct. However, we do need to have static here. Yeah. So, um, friends, normally you do not need to do this. However, for this exercise, we need to add static here. Otherwise, it's not going to work. Don't ask why. We're not teaching static today. And I know that might be frustrating, but I'm going to ask you to be patient. Okay? All right, so does everyone have this? And does everyone understand it? How else could I write this? What's another way I could write this? These two lines here. I actually did it the harder way. This is less so a function thing and more so a thinking thing. Yeah, go for it. No. Uh, for purposes of this class, since we haven't taught plus plus yet, how's that? Is that okay? Yeah. Same thing. Okay. Questions about this? Okay. Now, I want to register a new student. We already wrote a function to do this. How would I use that function? Can someone guide me on what to type? All right. So to call a function, you just do the function name, followed by parentheses, and then the input, right? However, we want to capture this input, so what we'll do is we'll say number of students equals that. Okay? Now, this is not a very useful example. It's just demonstrating how functions work. And then for purposes of demonstration, let's do system.out.println number of students. Yeah. So 6 will be substituted here, and then whatever is in here will be replaced with the output of this. Does that answer your question? Cool. All right, so everyone give me a signal when you have this written out. If you have all sorts of red squiggly lines or something seems wrong, let me know and I'll help you. Okay? Okay. series. I think what you have is correct. Probably ignore the first one. I'm not sure why it's doing that. We can look into it later. All right. Does anyone else have trouble? Anyone else have red squigglies? Yeah. Check. What the hell is it? Oh. Shift Option F. Why is it so different? Shift Option F. There we go. Quick thing, folks. If you have code written, and the text is the same, or at least close enough, but the spacing is all weird. On Mac, if you do Shift Option F, it'll format everything for you in Visual Studio Code. On Windows, if you do Shift Alt F, it will format everything for you. Where is my mouse? Let me test it. Shift Alt F. Yeah. F. F is in format. Or Alt Shift F. Yeah. Whoa. The hell?
I think another easier way of doing the article, you can have an extension, right?
Yeah.
I mean, you can download an extension of video code and then you just take out the format.
Yeah. Yeah. That works too. All right. So does everyone have this written, or something like it? Cool. Now, let's see how well you remember last week's homework. There is an easier way to run this, but we're going to do it the hard way because you may not always have Visual Studio Code. Okay, so again, we want to know how to do things at the bare level. All right, so up here, go ahead and click Terminal and click New Terminal. I'm actually going to do 2 terminals because, actually no, it'll be the same in Windows and Mac, so I'll just do 1 terminal. Why do I have 3? Get out of here. Okay. So now previously we did the command prompt in Windows or in Mac directly. We're going to do it in Visual Studio Code just so you don't have to navigate around. Say what? That doesn't seem right. Take a look. So terminal? Yeah. Terminal and then new terminal. There you go. Terminal up. Oh, you did. So you're here. You're good. That's okay. For Windows folks, your thing may say CMD or it may say PowerShell. I don't know why mine defaulted to CMD. I prefer PowerShell. Default to PowerShell, please. Much better. Yeah, that's the good stuff. Actually, wait, that's not the correct PowerShell. I want to use a different PowerShell. Where is it? That's the one. There we go. Again? Man, you guys release fast. Okay. Now, just for review from last week, we taught the whole moving around in directories. Okay. What's up? Problem? Huh.
So I was wondering, if I were to do this, what I do actually work. So strike off number, strike off 6.
Uh,
I remove number of students,
something like that.
and I put there 6. Would that work?
Yeah. Yeah. Variables and their contents are interchangeable. They're the same thing when it comes. It doesn't matter. You can swap between them easily. We're just doing it this way to demonstrate. That's it. There are definitely more efficient ways to do this. Like this function is completely unnecessary, right? But for purposes of demonstrating functions, that's why we're doing these. Yeah. So to review from last week's lesson, remember you can do cd to change directory. I can do dot dot to go. Now you don't need to follow along. Okay, I'm just demonstrating. I can do dot dot to go up a directory. So now I'm not in variables and methods. Now I'm back in Java, right? I can do cd and then the directory name to go back into it. Okay. On Windows, I can do dir to show what's in this directory. On Mac, hold up. How do I? No, I want to pick the shell, dude. How do I pick a new shell? I don't want a no, what? Is there not a way to? All right, well fine. Then I'll just do it the hacky way. There we go. On Mac, you can do ls. Okay, same thing. All right. So Mac, Windows. Windows is a little chattier, right? And then on both systems, so we have our lesson2.java file, right? You might need to, yeah, you need to cd into your lesson2 folder. There you go. So now if you do dir, yeah, there's your lesson2 file. So now remember, we have a Java file, right? But a Java file alone doesn't do anything, right? For the JVM to run our code, we need to create that bytecode file, that .class file, okay? Do you guys remember? Does this sound a little familiar? So to generate, what's up?
So if you make a directory like the way let's say I name my directory variable, do I have to call dot Java?
You have to go into that directory, and then you should have your file here.
No, no, I already have it. I mean, at the end of the directory, I just make variable. I need to put dot Java. I don't know what that's supposed to be.
I'm not exactly sure what you're describing, so I'm just gonna come take a look.
I'm gonna make a directory. I just created. This is the name of it.
Okay.
I didn't put dot Java. Would that be a problem?
So here's the thing.
This is.
Oh yeah, yeah, you're good. So this is the directory name. This is the file name. They're two different things. So here you're already in this variable directory, and then you have this variable.java. This variable directory that you created, there's nothing in it. Yeah. That's useless. You don't.
So it's okay, right?
Yeah, you're good. Oh, timing. I'll work with her on that later. Okay, so we want to take this Java file that has our code and convert it to a bytecode file, a zeros and ones file, right? Does anyone remember how we do that? Yeah, Java C, correct. So if you do Java C and then the name of the file, lesson2.java, if you run that, if you see nothing, what does that mean? It means you're good. Correct. Now, if you do dir on Windows, ls on Mac, you should see the .class file. Yeah? Has everyone got that? Cool. Now, we have that class file as our bytecode file. We're ready to give this file to the JVM. So now we do Java, and then we do the name of our class. Okay? So Java lesson 2. Ta-da. Sorry? Let me come take a look at your editor. Which one are you using? Oh, Untitled? Okay, yeah. So you just do, you go to tools. Oh, no, it's right down. Terminal. Now, IntelliJ and Visual Studio Code have stuff so that you don't actually have to do all this terminal stuff we're doing. We're just doing it as a practice. So you right, you don't have to do that. It's just for practicing. You need to do this. Do Java C lesson 2. Or whatever you named your file. 이거 기억 있어요? Yeah, here. We're doing on time. We're doing good on time. So now, it's going to put you in this folder already. So you can do Java C. Java C. And space. And the name of your Java file. So do that. So now, classify missing 이거 할수 있어요. 하지만 너의 class이름이 lesson small l. 그래서 Java lesson. So now I'll explain. Okay, so if everything ran correctly, oh, do you have a problem? Let me come check it. If it's quick, we'll fix it. If not, we can fix it later. So what you can do, so CD is change directory. We're going to change your source directory. Look, and see your variables and methods. So if we do Java C and then this file name, Studio Code also does that, but again, we're doing practice. Okay, so what happened here? Why did we get the number 7? Who can explain it to me?
Our initialization,
Yeah?
our number of students is 6,
Yep.
and we added 1.
Yep. Yep. So basically, this right here is the same as writing this. Same thing. Okay? So Sam is absolutely correct. So what happens is, number of students is passed as the input to register student. What is in number of students? 6. Okay? So that means current number of students gets set to what value? Correct. So then this becomes, just read this with the 6 substituted for me. Yep, 6 plus 1. And so that gets output and stored in here. Okay? Is everyone following? Cool. All right, so we have 15 minutes left. You guys are so fast. This is great. So that was practice together. Now you're going to practice alone. Okay? What's up? Oh, damn. Okay, let's take a look.
The problem was this one, the very beginning was 1. So yes, but I rectify it.
Now, here you go. This needs to be the same as this. So change this to variables. Yeah, change lesson 2 to variables. And then just work. So, yeah, go ahead and do that now. Now, labs, let's do your job. Variables. Yeah, let's take a look at it later. Yeah, sorry about that. Okay, so sorry for the delay, folks. That's really weird. I'll think about it. All right, so practice. Let us, and I'm going to write it up here too, so that everyone can read it after I say it. So as practice, yeah, that should be good. Define a new, no, no, that's going to be too complicated. Let's do, okay, cool. It's totally not true, but it'll be fun. Define a new variable to track the number of code bugs. Okay? Start it at 100. Okay? Then define a new method called debug Okay? Debug should take in the current number of bugs. Debug should reduce that number by 1 and return the new number of bugs. Print, execute debug once, giving it the number of code bugs, and print the output. Okay? So let's take maybe 5 minutes, 7 minutes, something like that to do this. And then we'll check it together, and then we'll make one minor change just as kind of an example, and then we're good. If you get stuck and you don't know how to proceed, ask me for help, but it should be very similar to what you already have. that maybe I did not write this very clearly, and if so, I apologize. So let's go over this together. So, new variable to track the number of code bugs. Who can describe to me how we could do this?
We can assign a variable to the
Yep. Good. Okay, so that covers this one. That's done. All right. All right. How about the next one? Define a new method called debug. How might we do that? This one. Define a new method called debug. It should take in the number of bugs. Say what? We're going to skip public for now. Generally, yes, but static. Yep. Yep. Let's call it current number of bugs. All right. Cool. And now, so that's this. That's good. All right. And now, whoops. Reduce that number by 1 and return the number of new bugs. How should we do this? What's -1? Current number of bugs -1. And what do we do with that? Cool. Like that. Okay, so that covers this one. All right. All right, now for this one, execute debug once, giving the number of code bugs as the input. How do we do that? How do we call it? Yep. Yep. Whoop. Yep. Yep. Cool. And what do we do with that? Okay, so so that's this one. All right. And then we want to print the output. We have two options. How do you guys want to do that? Where? Where should I type this? Where my cursor currently is, or next line? Like this? Are you sure? If we do it this way, there's something missing. Like this? And we did that here too. Oh, but you combine these into one line. Yeah, that's fine. Yeah. Cool. All right, so now I'm gonna, so first I made sure I saved, right? No white dot. Java C lesson 2.java. And then Java lesson 2. Oh, crap. Oh, lesson 2. There we go. 99. Yeah, good job, guys. Very good. Wait a couple minutes for people to catch up on this. And then there's one minor change I want to make, and then we'll call it a night. All right, great work, everyone. Um, so it should, yeah. So everyone's code seems to currently be working. There are some things we could do, like we could make this a constant, but we're a good bit over time, so we're not going to do that. But good job. To review what we covered today, you learned what is data, right? Zeros and ones and all that sort of stuff. You learned what a variable is. It's like a box. You learned the different data types: short, float, short, int, long, float, double, char, boolean, and byte, though we didn't really go over byte. You learned what constants are, same thing as variables, but don't change. And you learned how to use a function and method, and you learned how to define a function and method. So good job, everyone. Your homework is similar to what we did today, but instead of using numbers, you're going to use strings, okay? So you'll want to look back at these slides. We talked about strings a little bit. You'll want to look at that, okay? So you're going to define a function named print greeting, all right? It should accept two parameters. One of them will be called name, and it's going to be a string. The other is going to be called counter, that takes in an integer, okay? When this print greeting function runs, it should print out some greeting, you can decide what it is, to the name. Okay, so you're going to need to add that name to whatever the greeting is. Okay, and how many times it's been called. So you'll need to add a counter in there. Okay. Then you'll need to increase that counter by 1 and return it as output. Okay. And then in your main function, you need to initialize your counter as 0. And then I want you to call print greetings 3 times with different names. Okay? If you have trouble with this, and it seems like some of you might have trouble with this, that's okay. We're here to learn. Learning is not smooth. There's going to be problems, and that's okay. When you do this homework, if there's problems, message us on Discord. Okay? We're here to help. All right? So, any questions before we finish today?
If let's say if I wanted to check additional material on this online,
Hmm.
then
There are other materials. I will add them to these slides tonight. Okay. So if you just look at these later, they'll be updated. And after the event, or when I get home tonight, I'm also going to take this video, put it online, take these slides. The slides are already online, and I'm going to take the code we wrote, and I'll put that online. Okay. Any other questions? Cool. Well, thank you very much, everyone, for coming. And I'm just going to say this every time. We are a nonprofit. Donations to us are not tax deductible, but if you do want to donate, you can. The info is here. Additionally, thank you to W Coding for letting us use the space. If you want to do a programming boot camp, which will teach you things faster than here, but does cost money, you should look into their intensive program. Alex also works with us. Alex is the head of W Coding, and he is an excellent instructor. So that's a thing. He's not here right now. He's just the head of W Coding, and he's an instructor. That's pretty much it. Yeah, he was here last time. Yeah, but he's not here today. Yep. I'm sorry? You know what? I'm gonna add that to the slides later. But if you basically, I think it's just wcodingcampus.com. Okay? And all their stuff's in English. So, although Alex can speak Korean as well. So, if you want to check that out, go for it. Yeah. But cool. Thank you for your time, everyone, and yeah, thanks again, and see you next week. Next week we will be covering. Sorry, next week is. I don't remember what we're doing next week. Classroom. Next week is. I think next week is conditions and loops. Is that right? Yeah, next week is conditions and loops. So next week will be how to have your program make decisions, if this, then that, and how to loop things or do things many times. So do this 1,000 times, and it's like that. Okay, cool. Well, thank you everyone, and see you next week.